Welcome back. This is Mrs. Rubright with Algebra 1 Honors. Today's lesson is 9-1 Geometric Sequences. Alright, so in a geometric sequence, the ratio of the consecutive terms is constant. The constant ratio is called the common ratio, which is written as an R. Writing rules for the geometric sequence. So makers of Japanese swords in the 1400s repeatedly folded and hammered the metal to form layers. The folding process increased the strength of the sword. The table shows how the number of layers depends on the number of folds. Write a recursive rule and an explicit rule for the geometric sequence described by the table. Find the common ratio by calculating the ratios of the consecutive terms. Okay, so 4 over 2 is going to reduce to what? To 2, right? 16 over 8 is 2. 8 over 4 is 2. And 36 over 16 is 2. So your common ratio of R is 2. So all they're doing here is they're doing 4 over 2. Hold on, what are they doing? The ratio of consecutive terms. Okay, so they're doing 32 over 16, 16 over 8, 8 over 4, 4 over 2, right? That's what they're doing. Write a recursive rule for the sequence. So f of 1 is going to be what? F of 1 equals what? F of 1 equals 2. And f of n is going to equal your f of n minus 1, your previous term, times 2. So your previous term times 2. 2 times 2 is 4. Your previous term, 4, times 2 is 8. Term 5 is your previous term times 2, right? The first term is 2. Every other term is the blank of the previous term, and the common ratio is the product of the previous term and the common ratio. Write an explicit rule for the sequence by writing each term as a product of the first term and a power of the common ratio. All right, so f of n equals 2 times 2 to the n minus 1. Okay? So basically what they're saying is you're multiplying times 2 to the n minus 1. So if I'm doing term 5, 5 minus 1 is 4. 2 to the 4th is what? 2 to the 16th. Or sorry, 2 to the 4th is 16. And 16 times 2 is 32. It's 32. If I add 4, 4 minus 1 is 3. 2 to the 3rd, 2 times 2 is 4 times 2 is 8. 8 times 2 is 16. If I add a 3, 3 minus 1 is 2. 2 squared is 4. 4 times 2 is 8, and so on. Do you see how this rule works? Explain how you know that the sequence 412, 36, 108, 324 is a geometric sequence. The ratios of consecutive terms are constant. The common ratio is 3. So this divided by this is 3. 108 divided by 36 is 3. 36 divided by 12 is 3. 12 divided by 4 is 3. So it's times 3, times 3, times 3, times 3. Our common ratio is 3. A geometric sequence, geometric is what you're multiplying it by. Okay, your common ratio is what you're multiplying it by. A geometric sequence has a common ratio of 5. If you know that the 6th term of the sequence is 30, how can you find the 7th term? 30 times 5, 150. Writing general rules for geometric sequences. Use the geometric sequence of 6, 24, 96, 3, 84, 15, 36, and so on to help you write a recursive rule and an explicit rule for the geometric sequence. For the general rules, the values of n are consecutive integers starting at 1. Find the common ratio. All right, well, 24 divided by 6 is 4. 96 divided by 4 is 24. Right, so times 4, times 4, times 4, times 4. Your common ratio is 4. F of 1, F of 2, F of 3, F of 4, F of 5, and so on, right? Common ratio, R. All right, the recursive rule. F of 1 equals 6. F of n minus 1 times the common ratio of 4. Okay, here was the f of n minus 1 times your common ratio. Write an explicit rule. F of n equals f of n minus 1. Well, what is n minus 1? So we're going to go with the first term, 6, times 4 to the n minus 1. So your first term times your common ratio to the n minus 1. It's going to be f of 1, first term, times the common ratio to the n minus 1. The first term of the geometric sequence is 81 and the common ratio is 1/3. Explain how you could find the fourth term. All right, so your first term times your common ratio to the 4 minus 1, right? First term times the common ratio to the n minus 1. 1/3 to the third. 1 to the third is what? 1. And 3 to the third, 3 times 3 is 9, times 3 is 27. 81 times 1 over 27 is 81 over 27. 9 goes in here 3 times. 9 goes in here 9 times. 3 goes in here once. 3 goes in here 3 times. So it's going to be 3. What information do you need to know in order to find the fifth term of the geometric sequence by using an explicit rule? You need to know the first term and the common ratio. What is the recursive rule for the sequence f of n equals 5 to the 4n minus 1? So f of 1 is 5, right? That's your first term. And f of n equals f of n minus 1 times 4, where n is greater than or equal to 2. The term before it times 4. Or you can use this. First term times 4 to the n minus 1. Relating geometric sequences and exponential functions. The graph shows the heights to which a ball bounces after it's dropped. Write an explicit rule for the sequence of bounce heights. Represent the sequence in a table. All right, so f of n. So f of 1 is going to give me 100. 2 gives me 80, 3 gives me 64, and 4 gives me 51.2. Examine the sequence. Is the sequence geometric? Explain. So I'm going to take out my calculator. 80 divided by 100 is going to give me 0.8. 0.8 times 80 is 64. Times 0.8 is 51.2. This is times 0.8 times 0.8 times 0.8. So is it geometric? Yes. The common ratio is 0.8 or 4/5, right? 0.8 is 4/5. What is the common ratio? I'm just going to put it as 0.8. Write an explicit rule for the sequence. So I'm going to have the first term, 100, times 0.8 to the n minus 1. So the sequence has the rule f to the n equals 100 times 0.8 to the n minus 1. Where n is the bounce number and f of n is the height of the bounce in centimeters. A geometric sequence is equivalent to an exponential function with a restricted domain. On the graph above, draw an exponential curve that passes through the given points. Then write an exponential function of the form f of n equals a times b to the n, where a is the initial amount or y-intercept and b is the common ratio for the curve that you drew, and give the function's domain. Okay, so f of n equals 125 times 0.8 to the n. So if I plugged in a 1, they want you to say the domain. The domain is your x values, right? So what are my x values on my chart? 1, 2, 3, 4, right? How did I get the 125? If I did 80 divided by 0.8, I get 100. Divided by 0.8, I get 125. If I back it up to 0, I'd get 125. My y-intercept. Show that the explicit rule for the sequence is equivalent to the exponential function. Justify the steps you take. F of n equals 100 times 0.8 to the n minus 1. That's your explicit rule. F of n equals 100 times 0.08 to the n times 0.08 to the negative 1. Product of powers rule. F of n equals 125 times 0.08 to the n. Commutative and associative properties. So look, 0.8 to the negative 1, 0.8 to the negative 1 times 100 is 125. So all they did is they did this times this, and they got the 125. Okay? The explicit and recursive rules for a geometric sequence can also be written in subscript notation. The explicit a to the n equals a to the 1, the first term times the common difference to the n minus 1. Recursive is a to the 1 is given as a to the n equals a to the n minus 1 times r, for n is greater than or equal to 2. Writing a geometric sequence given two terms. The shutter speed settings on a camera form a geometric sequence where a to the n is the shutter speed in seconds and n is the setting number. The fifth setting on the camera is 1/60th per second. The seventh setting on the camera is 1/15th a second. Write an explicit rule for the sequence using subscript notation. Identify the given terms in the sequence. Okay, so a to the fifth is going to be 1/60. A to the 7th, they told us was 1/15. Find the common ratio. A to the 7th is A to the 6th times the common ratio of R. A to the 6th is going to be A to the 5th times R. A to the 7th is A to the 5th times R times R. So it would be the 6th times 1 more R. A to the 8th is A oh wait, am I just solving this? I'm not doing A to the 8th. Sorry. I'm plugging in. So A to the 7th is 1/15th. A to the 5th is 1/60th times R squared. So R squared is going to be 1/15th times 60 over 1. Which is 4, right? 1/15th times 60 over 1 is 4. So, square root both sides, positive, -2, right? So we've got 2. Find the first term of the sequence. So write the explicit rule, a to the n equals a to the first times r to the n minus 1. All right, so a to the n, 1/60th, equals a to the 1 times 2 to the 5 minus 1. 2 to the 4th. 2 times 2 is 4, times 2 is 8, times 2 is 16. When I divide by 16 on both sides, I get 1 over 960, because 1 over 60 divided by 16, or times 1/16, is 1 over 960. Write the explicit rule. A to the first, 1 over 960 times 2 to the n minus 1. So we're trying to solve for the first term. So we plugged in the 5th term equals the first term times the common ratio 5th term minus 1. We're solving for the first term. Once we have the first term, we plug it back in to solve. Okay? For any other term. When finding the common ratio, you can ignore the negative square root of 4 when solving the equation 4 equals r squared. Okay, so if r were negative, sum of the terms of the sequence would be negative. Negative terms do not make sense in this situation because the terms represent shutter speeds. Right? You're not going to have a negative speed. It's not possible to have a negative speed. If you graph the explicit rule for the sequence, what would the graph look like? The graph would be a set of discrete points showing exponential growth. We're going to do some practice problems. Write a recursive rule and an explicit rule for the geometric sequence. So what's going on here? What's my pattern? Times what? Times 3, times 3, times 3. So we know that our R is 3. What is our first term? 9. So we know that f of 1 is 9. And f of n is f of n minus 1 times 3, for n is greater than or equal to 2. So we're going to get f of n equals 9 times 3 to the n minus 1. First term times the common ratio to the n minus 1. The recursive rule is the answer before it times 3. The explicit rule, right, this is recursive. The answer before it times 3. The explicit rule is term 1 times your common difference to the n minus 1. So what's going on here? Times negative 1. So your common difference is negative 1. Your first term is 5. So f of 1 is 5. And f of n equals the term before times negative 1, right? That's your recursive rule. And that's for n is greater than or equal to 2, right? So now our explicit rule. What do you guys think the explicit rule is? What's my first term? 5. My common ratio, negative 1. Try number 3 on your own. All right, so what's going on? Times 1/4, right? Divided by 4 or times 1/4, times 1/4, times 1/4. So my common difference is 1/4. Common ratio is 1/4. And my first term, so f of 1 is 12. So my recursive is going to be the term before times my common ratio of 1/4 for n, and what? Is greater than or equal to 2. Then we're going to have our explicit. F of n equals the first term, 12. My common ratio is 1/4. The n minus 1. Let's see if this works. The fourth term. 4 minus 1 is 3. 1/4 to the third would be 1 over 4 times 4 is 16 times 4 is 64. 1/64. 12 over 64 reduces to 3 over 16, which is our answer. Right? 12 over 64 reduces to 3 over 16, which is the answer. So I plugged in one of the problems just to double check. Number 4. The table shows the beginning of month balances rounded to the nearest cent in her savings account for the first few months after she made an initial deposit into the account. Explain how you know that the sequence of the account balances is geometric. So what's going on here? What are we multiplying these by? Well, let's see. 2020.05 divided by 2010, 1.00, so this is times 1.005. Well, let's see. Times 2020.05. I got this, yes. Times 1.005, and I got the last one. So every time I multiply by 1.005, I got to the next number, so I know I'm good. I know that, so how do you know that it's geometric? Because it has a common ratio of 1.005. The recursive and explicit rules for the sequence of account balances. So your recursive is going to be f of n is the term before it times 1.005, right? The previous term times 1.005. Your explicit is going to be f of n equals your first term times, what's my common ratio? 1.005 to the n minus 1. What amount did you deposit initially? Explain. All right, so at 1 month, this is what she had. Well, what did she have at 0 months? So I'm going to divide by 1.005. 2010 divided by 1.005. I got 2,000. So she had $2,000 times 1.005 should bring me to the 2010, and it did. So she initially deposited $2,000 before it earned any interest. F of 0 is 2,000. You can plug that in. 0 minus 1 is negative 1. Negative 1 times, I'm sorry, not there, into here. 0 minus 1 is negative 1. So you'd have that, the negative 1 times 2010 is going to give you that 2,000. Our graph shows the numbers of players in the first 4 rounds of the U.S. Open's women's tennis tournament. Write an explicit rule for the sequence of players in each round. Okay. So our f of n equals term 1 times our pattern. What's our pattern? 128, isn't that divided by 4? Nope, divided by 2. 128 divided by 2 is 64, divided by 2 is 32, divided by 2 is 16. So 1/2 is our common ratio to the n minus 1. Right? This is your term 1, common ratio. Term 1, common ratio. All right, so how many rounds are there in the tournament? Hint, in the last round, only 2 players are left. If only 2 players are left in the last round, we're looking for it to be 2. Well, 16 divided by 2 is what? 8. We're going to have 8, and then 8 divided by 2 is 4. And then 4 divided by 2 is 2. It's going to be 7. Could I do this with math? Yeah. So f of n is going to end up being what? 2 equals 128, 1/2, n minus 1. So 2 divided by 128 trying to think of how I can do this. You don't know logarithms yet. If you did, you can use logs. And they want you to just kind of keep going down. If you were using logarithms, which you guys don't know yet, you could literally go log. You'd have log of 2 over 128 equals logarithm 1 over 2 to the n minus 1. You could bring that out front because it's a rule. So you'd have log of 2 over 128 equals n minus 1 times log of 1/2 divided by log of 1/2 and then add 1. Hello? No problem. Thanks. Bye. Jane, you have to go to see Miss Jackson. Alright, so if you did that, and then press the log button, divided by, parentheses, 0.5, log button, parentheses, equals, you have 6, plus 1, you get 7. You guys don't know logarithms yet, though, but that's how you would do it in upper level math, so you'd have 7 equals n. For this, for the purposes of this, you would just kind of continue the pattern, but if you wanted to know how to do it, you can put a log on both sides, and then exponents can always come out front. So you basically just have log of 2 equals log of, sorry, you divide out the 128 first. So log of 2 over 128 equals log of 1/2 to the n minus 1. The n minus 1 comes out front. And then you literally just divide out the log 1/2 on both sides. And you have n minus 1 equals all that nonsense, so plus 1. And you get n equals all of that. So you would do 2 over 128 log, 2 over 128 log, divided by 0.5 log equals plus 1, and you get 7. And that, my friends, is Algebra 2, which you guys don't know yet. But just FYI, it could be solved algebraically in the future. For right now, you would just kind of continue the pattern. So 16 divided by 2 is 8, divided by 2 is 4, divided by 2 is 2. Does that make sense? Okay. The number of points that a player must accumulate to reach the next level of a video game for a geometric sequence where a to the n is the number of points needed to complete level n. A player needs 1,000 points to complete level 2 and 8 million points to complete level 5. Write an explicit rule for the sequence using subscript notation. Okay. So for this one, a to the n equals, what is term 1? So we know that term 2 is 1,000. We know that term 5 is 8 million. Okay. So, what do we know? We need term 1, 3, 4. Alright, so this times something, times something, times something, times something 3 times is going to give you that. So isn't it 8,000 times the cube root of 8,000 is 20. So 1,000 times 20 times 20 times 20, that's going to work. 1,000 times 20 is 20,000. 20,000 times 20 is 400,000 times 20 is 8 million. So how I did this is I did 8 million divided by 1,000, and I got 8,000, right? This divided this was 8,000, and I had to multiply it by something 3 times, so I took the cube root, and that's how I did it. All right, so what is 1,000 divided by 20 is going to be 50. So first term is 50. You're multiplying by 20 each time to the n minus 1. This is your pattern. This is your common ratio. This is your first term. Yes. Yes. How many points are needed for level 7? So for level 7, 7 minus 1 is 6. 20 to the 6th times 50. 3, 2, 1, 2, 3, 4, 5, 6, 7, 8 zeros. So 3, 6. Okay. So that's going to be 3,200,000,000. Write an explicit rule for each geometric sequence based on the given terms of the sequence. Assume the common ratio is positive. I want you guys to try this one out. So what I did was I did 192 divided by 12, which gave me 16. And I had to multiply something twice to get to that, so the square root of 16 is 4. So 12 times 4 is 48, times 4 is 192. 12 divided by 4 was 3. So times 4 times 4 times 4. Common ratio, term 1 to the n minus 1. Does that make sense? So then if I'm doing this one, .0128 divided by 0.32 squared, it's 0.2 times 0.32, 0.064 times 0.02. What was it? Times 0.02? Is that what it was? Times 0.2. Times 0.2. Okay, so then divided by 0.2. So 0.32 divided by 0.2. This one would have been a to the n equals 200. 0.2 to the n minus 1. Each rule represents a geometric sequence. If the given rule is recursive, write it as an explicit rule. If the given rule is explicit, write it as a recursive rule. Assume that f of 1 is the first term of the sequence. Okay, so number 9. Term 1 would be 1 minus 1 is 0. Anything to 0 power is 1. 1 times 6 is 6. So then you know that f of n equals the term before times the common ratio of 3, for n is greater than or equal to 2. This one they gave you that term 1 is 10. They gave you that the term before times 8. So we know that this is the common ratio. This is the first term. First term times common ratio to the n minus 1. An economist predicts the cost of food will increase by 4% each year for the next several years. 0.04 is your common ratio. Use the economist prediction to write an explicit rule for the geometric sequence that gives the cost in dollars of a box of cereal in n years that costs $3.20 year 1. F of n equals $3.20 times the common ratio to the n minus 1. Make sense? Term 1. Common ratio to the n minus 1. What is the fourth term? Year 1 times common ratio to the 4 minus 1 to the third. 0.04 to the third times 3.2. Hold on, did I do something wrong? 0.04 to the 3 times 3.2. What did I do wrong? Oh, duh. It's increasing by 4% each year. So it's 104% that I'm looking for, right? I knew my answer didn't sound right. I'm like, how is that possible? That doesn't make sense. It doesn't make sense because it's 104%, right? It's 4% more than the original. So 1.04 to the third times 320. 359.9, so it's going to be $3.60. That makes way more sense. $3.60. The cost of the box of cereal, right? Year 4, the cost of the box of cereal is $3.60. All right, guys, so for your homework, you're going to do pages 501 and 502. I hope you guys enjoyed this lesson on 9-1. Please like and subscribe and have a fantastic day.